This question is from GATE 2018 Mechanical Engineering paper set 1, question number 30. An epicyclic gear train is shown in the figure below. The number of teeth on the gears A, B and D are 20, 30 and 20 respectively. Gear C has 80 teeth on the inner surface and 100 teeth on the outer surface. If the carrier arm AB is fixed and the sun gear A rotates at 300 rpm in clockwise direction, then the rpm of D in the clockwise direction is dash. Let's find out. So as the carrier arm AB is fixed, that means velocity of AB or angular speed of AB will be 0. So we can take the absolute velocities of all the gears. Let's write the other given things here. So teeth on gear A, teeth on gear B, teeth on gear D, teeth on gear C in the inner surface and teeth on gear C on the outer surface. All of them are given. A has 20 teeth, gear B has 30 teeth, gear D has again 20 teeth. The gear C is having 80 teeth on the inner surface and 100 teeth on the outer surface. We are also being given the angular speed of gear A in terms of RPM. So NA is given as 300 RPM clockwise. Let's assume clockwise to be negative. So minus 300 RPM. Now we can write the relationships between angular speeds of the meshing gears with the teeth of the meshing gears. So we'll start by writing the relationship between gear A and gear B. So NB by NA will be equal to, these are externally meshing gears, so minus TA by TB. Then we can write down the relationship between gear B and gear C, but B is meshing with the internal teeth of gear C. Therefore, we'll write the relationship as NC inner by NB will be equal to the inner surface of C meshes with outer surface of B, and therefore this ratio will be TB upon TCI. It will be a positive ratio, not a negative one. Also, we can write a relationship between gear D and gear C. So ND upon NC naught is equal to minus TC naught upon TD. Negative because these are externally meshing. Now we know that gear C will have the same RPM for inner and outer surfaces. Therefore, we can write NCI will be equal to NCO will be equal to NC. From the first two relationships, we can multiply the two and we will get NC by NA, because NB by NB will be 1, will be left with NC by NA, and on the right hand side again TB by TB will be 1, so we'll be left with minus TA upon TCI. Now NA is known to us, so we can find out NC from here. NC will be equal to minus 20 upon 80. Value of NA is given to be 300 RPM but negative because it's clockwise. So we take into minus 300. This gives us 600 by 8. This term is a positive term. Then we put NC here in order to get ND. ND will be equal to minus TCO is 100 upon TD is 20 into, here it was in denominator, NCO was in denominator, so we take to the other side, it will be into 600 by 8. So this gives us the answer as minus 375 RPM. We are getting a negative value, that means the direction will be clockwise. So which is equal to 375 RPM clockwise. And we are being asked what will be the velocity in clockwise direction itself. So when we take it in clockwise direction, we should write the positive value, because negative sign here is indicating clockwise and it is being asked clockwise. So actually the answer will be positive. Let's go back and fill in the answer. So the answer is 375 RPM. It's not negative, it is positive. To learn more about gear trains, you can refer to the NPTEL video, lecture 39, Gear Trains 2. It's from the course Kinematics of Mechanisms and Machines. The course is taught by Professor Nirvan Dasgupta. He is from Department of Mechanical Engineering of IIT Kharagpur. I hope the solution will help you clear your doubt. Thank you.